We are live. I see all people rushing full speed into your mouth as moth dash destruction in a blazing fire. O Vishnu, I see you devouring all people from all sides with your flaming mouth, covering all the universe with your effulgence. You are manifest with terrible, scorching rays. O Lord of Lords, so free, so fierce of form, please tell me who you are. I offer my obeisance unto you. Please be gracious to me. You are the primal Lord. I want to know about you, for I do not know what your mission is. The Supreme Personality of Godhead said, Time I am, the great destroyer of the worlds, and I've come here to destroy all people, with the exception of you, the Pandavas. All the soldiers here on both sides will be slain. All right, that's a
Wow.
slightly different alteration than the famous, than what Oppenheimer said, which is now become Death, the Destroyer of Worlds. So I was quoting here from the Bhagavad Gita,
Wow.
this ancient Sanskrit text, uh, one of the jewels of India's spiritual wisdom, I will say. And yes, there seems to be commentary from the unknown person in the background. We might
What
as
are we
well bring him
doing?
to
What?
the
Yeah.
What is this? Well, first of all, who are you, Leonard? Good to see you. You look good.
Hey, Shen. What up?
Yes, we're both dressed in blue. What the coincidence? What? You know?
Yeah.
How coincidental, right?
What are we doing? I mean, I was clicking on a link that said something about Oppenheimer.
Yes, yes.
Something.
So this is episode 230, and episode 230 of the show that, yes, if you can believe it. And today we're talking about, well, as you can imagine, Oppenheimer, whom for I think most people, maybe some people now know about him with the movie that came out last year, which I did not see, by the way. But so, anyways, Oppenheimer, particularly the American physicist who led the Manhattan Project, J. Robert Oppenheimer, and yeah, and often called the father of the atomic bomb. Of course, he's also known for some other things. And today we're going to go into who Oppenheimer is and how this is related to the fallout of idealism, which is an interesting topic of its own. So with that, let me ask our esteemed scholar here, you, Leonard.
Who's that?
That's you. All right. So can you tell me a little bit about Oppenheimer's family background?
Oppenheimer. Okay, his name was Julius Robert Oppenheimer. He went by Robert. They may have called him. I don't think they called him Bob.
That would have been interesting.
Yeah, that would have been interesting. He was born on April 22nd, 1904. And his father was a wealthy German Jewish textile importer. And they were also, his parents were very well-to-do. They lived up on the Upper West Side of Manhattan. He was some kind of textile importer. And he was not in the garment business, which was famous in New York in those days, but he had customers who used his textiles, and he imported silk and good stuff like that. And his mother was brilliant, intellectual. She was a cultured artist. Her name was Ella Friedman Oppenheimer.
Friedman. Okay.
Ella Friedman, and they were sort of assimilated German Jewish people. They belonged to something called the "our crowd," which was an idiom that was used to apply to, kind of hoity-toity. Is that a word? Hoity-toity?
That is a word.
Yeah. So he always they were very indulgent of his interests and curiosities about things, and so his house was filled with books, art, music. And I think they had lots of people over to talk about cultural and technical and politics and things like that. And all through his childhood, he was identified as a very precocious, very serious, somewhat shy child, right? and he showed a very early aptitude for science, literature, languages, even. Like I said, his parents very much nurtured this. So anything that he was interested in, if he was interested in collecting rocks, well, they started working on that for him, and they were very wealthy. I think they had an apartment on the Upper West Side with 10 rooms. I think they had a house I think they had a house on Long Island or Staten Island, probably Long Island. They had a sailboat, and so that gives you an idea of what kind of life he had as a child. So he had I think he was, very precocious. They started him at a school called the Ethical Culture Fieldstone School, or Fieldston School, and this is this is something I didn't know about. Ethical Culture Fieldston School was founded in New York City by a guy named Felix Adler, and it grew from really an outgrowth of the Reform Jewish movement in and it combined a curriculum of blended humanities, fostering intellectual growth, and so he developed a sense of civic duty, and he attended this school. So it was like, I think all the way through, I think it went from K through all the way through 12th grade. So that was his early child. He excelled in school. So but he was also, as you might imagine, socially awkward. And I might add some anecdotes about that later when he ended up in graduate school.
Like, being socially awkward seems like a common attribute of all nerds, I would say.
Yeah. Well, he would have been identified as a nerd, but I don't think he was on the spectrum or anything like that, because unlike some of people we know, but I think he ended up being very well adjusted, and he was able to eventually be a very good manager. And we know that he was instrumental in developing the atomic bomb.
Yeah, I mean, you can't not have social skills, I suppose, to be able to lead a whole team. Absolutely. So,
but so this is, we're talking about his life during the 1920s, when he was, early preteen, early teens, and he was very passionate, I would say, about literature, languages. He learned, not only was he gifted in science, but he could also speak all different kinds of languages. At one point, he even got interested in Sanskrit, and so
that's how he knew about the Bhagavad Gita, right? Since he obviously has read it.
I think so.
Yeah.
So there, there's these anecdotes, traits, and anecdotes that suggest he was awkward, especially in his younger years. But he was intensely intellectual, shy. He was physically frail, and actually, if we have, most of us have seen pictures of him.
Yeah, I was actually trying to display it, but then I realized my monitor settings needs to be adjusted a little bit. So, but keep talking. I will get a picture of him.
And perhaps a little bit aloof. I mean, he may have suffered from some depression. There's a famous breakdown incident, emotional breakdown incident that involved his professor in either graduate school. I think in graduate school. But everybody that came in contact with him described him as fairly charismatic but distant. If that means something, he could fly into some sudden mood swings, changes. He would become very deeply absorbed with his own thoughts, but he had a magnetic presence later in life, and so he kind of grew out of all of those personal remoteness characteristics. He was the school that he went to, high school. high school that he went to was very prestigious, and he was accepted to Harvard in well, he was accepted to Harvard, I think, in 1922, 21 or 22. He took a year off between high school and college. He was sick at some point, and
what year are we talking about here?
so he was 18 in 1922. So he had graduated high school at that point. He had been accepted to Harvard. He was, I wanted to relate another anecdote that I had heard about him. He became very interested in geology at one point. This is as a teenager, and his parents made him, gave him lots of support in that area. So he was like collecting rocks, and there was, and I don't know I don't have it in my notes. What the organization was that he was that he got affiliated with, but it had to do with a rock collection or a geological society, and they didn't even know that he was like 15. And so he gave a paper to this geological society, and was well received. So he was a very brilliant. He was among the smartest people that any of us have ever met. So, but the thing is, between high school and going to college at Harvard, he traveled to New Mexico with a friend, and they went out there. I don't know what brought them out there exactly. He was sick. He had a brother named Frank, and they went out there together and rented a cabin.
This was just for fun, right? Like
this was
vacation?
for fun. This was for fun and to look the land over. And maybe he was ill. He was recovering from some stomach issue, and so maybe somebody said, "Go out in the Southwest where the air is clear." And but he literally fell in love with that landscape, and
the desert landscape. Yeah,
they rented a cabin in a place called Perro Caliente with his brother, and eventually they bought property near Los Alamos. And this becomes important later on. Los Alamos, New Mexico. This becomes important later on because this influenced where they located the Manhattan Project in later years, which we'll get to be talking about in a little bit. So they actually did buy some property there, and I guess he went out there to meditate with the deep emotional spiritual connections and so forth. He made an occasional life for himself in New Mexico throughout the rest of his life. So in college, he initially majored in chemistry. From 1922, he graduated in 3 years. From 1922 to 1925, he initially was studying chemistry because that's what he was doing in high school.
He went to Harvard, right?
Harvard. Yes.
Okay, you have to talk it like that. Understood.
And then he gradually became realized that he was more interested in the theoretical aspects of nature, and he shifted to physics. Chemistry has a lot of concentration in laboratory work, and there's no question he was fairly inept in that area. And it kind of, and later times he had some.
Are you saying that he realized that he was not good at doing experiments?
Yeah, not so much doing experiments, but doing the laboratory work. And also chemistry is more sort of prosaic, where you're just learning about what you're doing. Is you're taking the test is, they give you a test tube with some unknown substance, and then you're supposed to go through a rigorous process of identifying what the substance is. And so it's not that.
Yeah, I see your point. Yeah.
I mean, and things like that, I'm sure, were the things that affected him. But he shifted to physics, and like a lot of us shifted to physics. So,
yeah, I mean, you're talking about yourself. I mean, I studied physics as well, so it's great.
But he ended up graduating summa cum laude in
How
3 years
impressive.
from college. And not only did he study physics and he and chemistry, um, he had a broad background. He took classes in literature and philosophy, and um, so he did very, very well at Harvard
Wow.
and got lots and lots of recommendations when he left. He was famous for writing long philosophical essays instead of letters. You know, so I'm not sure. Different things like that. So, um,
Like what you mean? Just writing it for his own
he no,
reason?
I think when he would write to people in those days, people would write like
Let me
maybe
see.
you've never haven't seen this, but you can actually take paper and a pen and you
I
can
hey,
like
I write all the time, sir.
yeah. Well, but a lot of people may not be familiar with this
Like
process.
I mean,
So
no,
yeah,
no, no,
so,
but like like the typ of writing that he's doing, he's expressing his philosophy about, I guess,
he seemed
everything.
yeah, he seemed to have a need to do that. So
Interesting.
so I guess that's kind of a picture of who he was up through college and then graduating college
So
in
he definitely
1925.
sounds like a very much like a very well-rounded individual with
Very well rounded.
yeah,
I am sure that he was identified as being among the top scientific personalities or
right.
students in of that era. So he matriculated into he went past that and went to postgraduate studies or really graduate school at the
Hmm.
University of Cambridge. So he was at Thomson's laboratory, Cavendish laboratory, which we've talked about before because that's also where Niels Bohr was
Right.
educated and a number of other people. So he didn't do well at Cambridge. He studied. He did get affiliated with J.J. Thomson at the Cavendish laboratory, and like we said, he struggled with the experimental work. He felt kind of alienated, and he ended up in a kind of emotional crisis. So the story there is, and we don't know the whole details about it, but it's known as the alleged poison apple incident, and
What is
this is
that?
it's astonishing to me. Okay, so while he was studying there, it seemed like he was starting to get depressed, and he was feeling very inadequate because he was very smart. He knew he was very smart.
Hmm.
Uh, I think most people thought he was very smart, but this was not his. This wasn't where he belonged. Doing
Right.
this experimental work, and he was frustrated, and he seemed to have become a little emotionally unstable. So here's the story. He allegedly tampered with an apple that was intended for his I guess his thesis advisor, Patrick Blackett. Blackett was Nobel Prize winner and had a lot to do with the work with um, you know vacuum chamber
Wait,
physics.
who's the what's his name? Blackett?
Blackett,
BLACK.
Blackett,
Yeah.
Patrick.
Okay. Oh, okay. Yeah.
And I don't know, Thompson himself referred to this sort of tangentially, and there were other people who mentioned it, but he seemed to have tampered with the apple with some kind of chemical, and it's known as the poison apple. Now, Blackett never ate the apple, um, and it was kind of quietly handled with it, but it's a very strange story, and to me, it's kind of
That is
disturbing.
great. Oh, that was in the movie, even though I haven't seen it, by the way.
Oh, I
I don't
have
know if
seen
that's
the
it.
movie. I don't remember them mentioning that in the movie.
Oh, okay.
I've seen the
Ah.
movie,
Hey,
and we'll talk about the movie in a little while.
so the guy Blackett was actually his mentor at that time, right? So
I think his research advisor,
right. So
what we
basically
would call,
he tried to poison his own advisor at that time.
yeah, and
That's wild.
it's completely unclear. It may have been something like this. Well, he was stressed out about something,
Right.
and he put some, I don't know, maybe maybe it was just chili pepper or something. Let's hope it was just that's all it was. But
Let's
he
sure hope.
wanted,
Yeah.
yeah,
Regardless, Blackett did not eat the apple, didn't die, nothing really
didn't
happened there.
somehow, and evidently it also didn't come up in his security clearance hearings later on during the time of the war,
Okay.
because that would have been something
So
that we'd want to know about.
this is in the still in like the mid 1920s. So Europe at that time, there was a lot of I mean, obviously the war hasn't started. There was a lot of good science coming out of there, especially in the UK and Germany.
The incident was handled internally by the school, and they just made it go away. I mean, his parents were pretty wealthy and probably could smooth things over with a large check.
If you're pretty wealthy, you can make these things go away, I'm sure.
So from there, From there, he went to study with Max Born. So that's more like the theoretical areas that he'd be interested in, and that was at Göttingen, which is a school that we've talked about before in
Göttingen.
Göttingen. Yeah, University of Göttingen from 1920.
Oh, that's right. Yeah. I think we did talk about that. Yeah.
So this is part of the circle that included Heisenberg and Pauli and Dirac.
Basically, all the physicists who revolutionized physics as we know it in the early 20th century, like were at that university or affiliated with it.
Yeah. So that was a very prominent. That's a very prominent German
University of Göttingen.
And I think it's pronounced Göttingen. In German, it would be Göttingen. So, but you know.
Heck,
but
I know.
It doesn't matter. All
right. Point is, he went over there and started studying under Max Born.
So. Yes, he studied, and so his research contributions about understanding how electrons behave in an atom and molecule, and so he developed this. He developed a great faculty with quantum mechanics and quantum electrodynamics. So actually, in my own education, this is where he developed what's called the Born-Oppenheimer approximation, and that involves, like, if you have an atom, then the electrons are all moving around very quickly, but the nucleus is stationary relative to the electrons, and so you do the quantum mechanical calculation as though the nucleus were stationary, and then solve for the locations.
Widely used in quantum chemistry to speed up computational molecular wave functions.
That's right.
This is approximation? Wait, so like you just add these terms together?
So it's a perturbation method. So then you solve for the locations, you solve for the state of the electrons, and then you solve for how the nucleus is perturbed by that, and so on. And so you will do that iteratively, and that's well known. Like if you take quantum mechanics at the graduate level, I don't know about undergraduate, but if you take it at the graduate level, you'll come across the Born-Oppenheimer, and this isn't what he got his PhD for. I think his PhD was something else having to do with molecular systems or energy levels. But it was all in that same lab at Göttingen, studying under Max Born. And I think, but by the way, I believe that he was fluent. Oppenheimer, I believe, was fluent in German.
I would assume he must have in order to work with all the German physicists of the day.
That's right.
It would be hard to communicate. Otherwise, I would imagine. That's really interesting. So he worked with Born and actually came up with a very important
physical theory. So after graduate school, that was graduate school. That's where he finished his piece. He started at Cambridge, and he kind of like.
Cambridge was not for him, clearly.
Yeah, it wasn't for him. So he moved to he continued his studies in Germany, And so it kind of gives you an idea how eclectic he was and how well connected he was. And so the rest of that time, for about a year and a half after he finished his PhD, he
Mhm.
started like touring various laboratories all over Europe, including he worked with Paul Ehrenfest, who was involved in like
Uh,
statistical mechanics, quantum theory,
so before
and more
you,
thermodynamics.
what is this laboratory? Let me see. This one.
Leyden. Oh,
Oh, Owen's laboratory, was that? I guess that was one of the other ones. Like when he was going on the European tour to go to different labs.
that's in Leyden.
Leiden,
Yeah,
yeah.
yeah. That's the one I'm talking about. That's
Oh,
where
that is the one you're talking about.
yeah
Okay.
he studied with Paul Ehrenfest. Ehrenfest was interesting because I think he committed suicide in
Uh,
he-
does that
yeah.
makes it interesting? Okay.
Well, I mean, a lot of these, a lot of these, we've been studying these guys for a while, and a number of them kind of like had some emotional problems. And if you remember when we talked about Carl Jung um, and um,
It's
Wolfgang Pauli, and so forth.
yeah,
So,
absolutely.
yeah, and
So in this picture, he's in the middle row, second from the left. So
that's awesome.
is that this
Yeah,
guy? Second from the left. Oh, this guy. Yeah, that must be him.
I've seen
Yeah.
this picture before.
Yeah. They seem very sharply
Oh, there
dressed.
he is.
Which one is this one, right?
Yeah.
Yeah. Okay, cool. Huh. Interesting. All right, back to you.
So anyway, and so he really thrived at in all well, he really kind of came alive after his PhD, and what he was doing, this was deliberate. This was an effort to try to enhance his reputation. He wanted to be somebody very special and very important in the physics world. He also visited Copenhagen and Berlin and Munich, and the whole purpose was just to absorb all of the cutting edge of modern physics, all of the quantum theory that had just become mature by 1930, say, or between 27, 28, in that period, and then also to build a network of people. That's what people. So he visited these other physics centers. He did now at this point he didn't have any students of his own, but he had finished his PhD, and he was getting to be well known. So he had met everybody. He had met Heisenberg and Pauli and Dirac, Enrico Fermi, and all these people that would later become important at the time of the war. So that was one of the things that gave him some credentials, some gravitas. So when he started looking for a job, he wanted to return to the States, and I don't know if he considered various places, but he was offered. I think we've talked about Einstein had eventually ended up in Princeton. Princeton really was not quite developed yet at that point. Institute for Advanced Research.
You're
or
saying their physics program isn't quite
There,
what we know
well,
them as
it
today.
was called the Institute for Advanced Studies at Princeton.
Okay.
That really didn't get going until a little bit later. So he ended up at Caltech and also UC Berkeley as kind of like dual faculty.
Mm-hmm.
And I forgot exactly, like Caltech, which is in Southern California, uh, would have, like, I think they had like a semester system, and UC Berkeley had a quarter set system. So he would do I'm probably telling it wrong, but he would do a spring semester at Caltech, and then a fall semester and a winter quarter at Berkeley, or maybe it's the other way around. So that was his job, and he enjoyed that intellectual environment. He yeah. So and
So,
and
so he was going in between Harvard and Caltech.
no, not Harvard. He had
Oh,
graduated from Harvard.
okay.
he took a position at Caltech and
Mhm.
UC Berkeley.
UC
UC
Berkeley.
Berkeley, yeah,
Got it.
UC Berkeley. We know where that is. That's
Okay, so still on the
you
West
don't
Coast, both of them. Yeah.
you don't remember the Summer of Love, okay? But this was
Oh
long
my
before.
gosh. Did you experience that, Leonard?
This was 50 years before that. So at
Yep.
Caltech is Southern California. UC Berkeley is up there in Oakland, near San Francisco, right? You get the picture?
Yeah, I get the picture.
Okay, you can drive like it's like a
Yeah, yeah, yeah.
5 hour drive, right? Okay, so as a professor at Berkeley and Caltech in the 30s, Oppenheimer really became a brilliant and very influential teacher. He attracted a lot of talented young physicists who would become prominent in their own right.
If you don't mind me
Including
asking, so we went from his Europe days to him now becoming a professor at American universities. Why did he return to the United States?
I think because America is home.
Okay.
Okay, he was, uh, I think that was his thing. He kind of developed some uh, uh, credentials in Europe among the most important people
Right.
in that area, and then he wanted to work in America, and so he had a number of students, including David Bohm and some others. There was one of his students was a Melba Phillips, who was an American physicist, and she earned her a PhD at Berkeley under Oppenheimer, and she made contributions to theoretical physics, including something called the Oppenheimer-Phillips process, which I didn't really know about. But it explains certain kinds of nuclear reactions involving heavy hydrogen nuclei. She was also influential physics. I just wanted to mention her because you don't hear about women very much, but he had
Oppenheimer-Phillips process.
Yeah.
That's
And a number of these people were very important later on when we start talking about the Manhattan Project. So he was known for rigorous, intense teaching style and for inspiring deep intellectual engagement, shaping and this really wasn't like a whole generation of physicists in America. So he was much more important than people kind of give him credit for. But
interesting.
there's also another physicist was Willis Lamb. He has a shift named after him.
What?
The
A
Lamb
shift?
shift. Yeah,
Lamb shift?
Lamb
Like
shift.
LAMB shift?
LAMB shift. See if that comes up.
Difference in something.
I've actually forgotten what it is, but it had to do with spectra.
An anomalous difference in energy between two electron orbitals in a hydrogen atom. So how is Oppenheimer related to this?
Oppenheimer was Lamb's professor.
Oh wow! Okay. So
and then the really phenomenal thing about Oppenheimer was that his research included the quantum electrodynamics, which was later developed into a really important theory in the 40s and in the 50s, and right on up to today. But he also had something to do with cosmic rays, nuclear physics, and even astrophysics. And I know him best for his astrophysical work having to do with some early speculation, not really speculations, but early rigorous calculations on the nature of black holes, including the time dilation near the surface of a black hole. So he wrote a paper in, I want to say 38. I'm kind of shifting forward, 37, 38, somewhere in that time frame, where he discussed this idea of a cloud of dust, and that the dust would self-gravitate and all come together. And so people were including Einstein, were um,
Hmm.
thinking about those kind of things. So they thought that most physicists thought that it didn't happen for some reason. Meaning, he speculated. He didn't use the word black hole, but he speculated that when dust would self gravitate down into a singularity, that
Mhm.
it would collapse and just keep falling. In other words, it would keep falling into a gravitational singularity. The modern sense that we have of what a black hole is. So,
Is
and
it the wait? Sorry, maybe I'm getting ahead of myself. But Oppenheimer Snyder model, or is that something else?
that seems to me Snyder. There was
So
the name
that's
Snyder.
yeah, like in well, I just looked it up since I didn't even. I
Hmm.
had yeah, it's like 19 published in 1939. Here, I just
Okay, a little later than I thought.
yeah, so during the collapse of a star to a black hole, the geometry on the outside of the sphere is a Schwarzschild geometry. However, the geometry inside is curiously enough the same Robertson-Walker geometry. So that's
Yes.
the
Okay.
observable universe.
So when you read really really fast like that, you start to become like a Gen Z.
Okay,
Uh,
let me read
yeah.
slower. In
Yeah.
general relativity, the Oppenheimer-Snyder model is a solution to the Einstein field equations based on the Schwarzschild metric describing the collapse of an object of extreme mass into a black hole.
I
Named
couldn't have said it
after
better.
physicist J. Robert Oppenheimer and Hartland Snyder, who published it in 1939.
Okay, 39. So
So,
yeah.
I
So
guess
that's
so.
so
Yeah.
so so he was awesome. Okay.
Wow.
So
There you go.
so uh
Maybe
so
that
so
equation.
so the picture you need to have of him in the 30s, 1930s as a professor of physics
Hmm.
was he was a very, I don't know what's the word for somebody who's in a lot interdisciplinary, but
He
not,
yeah,
he didn't just dabble in these areas. I mean, he made real contributions in
he
all
made
those
real
areas.
contributions in a number of different areas of
Yes,
physics. Right.
that's right. That's right.
Yeah. Which is
So
really impressive. Yeah.
I think it is. Yeah.
I mean,
So
for sure.
the other thing that was happening in the 1930s, some of us may have heard about it. There was this thing called the Great Depression, and there was something going on in Europe about something called fascism, and so
Yes.
he was, and because he was also from like a non-religious Jewish family, he was
Hmm.
kind of drawn to left-leaning intellectual
Hmm.
circles, particularly in Berkeley and San Francisco, and he actually did contribute. We know about this because they had a background investigation on him. He contributed money to causes that supported the Communist Party, and aided the left wing side in the Spanish Civil War, and other things like civil rights and
Hmm.
friendships and even romantic relationships with individuals who were in the Communist Party. So, including like his wife was Kitty Puining, and he also had this woman he had taken up with named Jean Tatlock. She was a psychiatrist. She was a psychiatrist, and so he was how do we say this? He was he was married to
He was he was
Puning, and also having I
was he
don't know how
having
to
an
say it
affair?
delicately. What?
He was having multiple relationships. Is that
Well,
what you mean?
not multiple, but another relationship with
Another
a
relationship.
woman who was not his wife, Jean
Yeah.
Tatlock.
Okay.
Okay, so so these were left wing.
Gene Catlock.
Actually,
Okay.
yeah, all having to do with Communist Party. So he was all
That's
he was at dinner parties and talking to people and hanging out with communists, right?
right.
So um, and so you know
So
um,
he was involved with her.
yeah. So Jean Tatlock was, and she Actually, she died early. She only died
Oh,
when she was about,
she killed
about 30.
herself. That's sad. Yeah.
Yeah, she was a psychiatrist, writer, political activist, and she became romantically involved with Oppenheimer during the 30s. So she became politically engaged, and she was a member of the Communist Party. And she did things like she wrote for some kind of news publication, communist. So he met her in 1936 in San Francisco, which is San Francisco's kind of a place where you can meet communists.
That's
So
yeah.
I mean that's where all my communist friends live. So and
Okay. Wow,
So-
they've had a really interesting relationship, huh?
yeah,
Proposed
And,
her twice, but she refused. Yeah.
yeah, and so yeah, she committed suicide. And
They
her
continued seeing each other even after Oppenheimer became involved with Kitty Harrison. Yeah. Okay.
Right. So it did fuel some suspicions later on about there was questions about his loyalty the whole time, right? So it was scrutinized, what I should say. So I think it's probably true that he was sympathetic to a lot of left-leaning kind of
Right.
causes. Right.
Oh, yeah.
Yeah.
It says here in the 1940s, homosexuality was seen as a pathological condition to be overcome, which may have led to her eventual suicide. Huh. That's interesting and sad. But
Yeah, it's kind of sad. So, but anyway, and it caused him troubles, later on.
because they assumed like this was during like the Red Scare, right? Where since he was
after the war, there was
after the war.
After the war. But the thing is, during the 1930s, there were lots and lots of people who had this idea that capitalism, didn't work, and that was because of the Great Depression.
Right.
That's also part of the reason that why there was a rise of fascism. It's like we can't just have everybody doing whatever they want. We need to have everybody under control so that we can move forward with order and progress.
So the developments of both communism and fascism came about because of people were looking for solutions outside of the
that's right
model.
That's right. Order and progress.
Right. So okay.
By the way, did you know, this is an aside, did you know that order and progress is on the Brazilian flag? There's like some kind of globe and a banner on it, and it
says order and progress.
In Portuguese, it says something like order and progress. So it always kind of.
I don't know anything about the Brazilian flag.
Yeah, the Brazilian, the flag of Brazil.
You found that out recently?
No, I've known it for years. I've always wanted to get
right. Ordem e progresso, meaning order and progress, prominently displayed on a white band within a blue circle.
Yeah, huh. I always thought it was sort of provocative. Like
order and progress. Is that what's also the like? Is that a fascist saying? I don't know.
It sounds vaguely fascist to me. Yeah, but that's just me. I think we meant.
Wow.
I think with respect to the Nazis, we used to talk about blood and soil. So this is order and progress, right? But the reason I brought that up was that this was a thing during the 1930s.
Blood and soil is affiliated with Nazi Germany, I think, right?
Yeah.
Yeah. Okay.
So there are these little aphorisms or sayings that and so I don't really have anything else to say about that. I mean, I've talked to the mothership about it. They don't really understand it either.
But humans are strange. You got to come up with slogans, I guess.
Humans are strange.
I mean, I suppose you shouting those slogans somehow make yourself feel like you're part of a larger group that is doing something that is right.
Yeah,
I
think so. So this was the climate in the 1930s, and so it could have contributed to lots of intellectuals who were attracted to this kind of ideology. And I
Right.
don't have any doubt that personally, I don't have any doubt that um, that
So even Oppenheimer's wife, you said, was affiliated with that, right? With
yeah,
communism. Yeah.
I
So
think that but on the other side of that is I don't think he was disloyal in any manner.
right,
I don't
right.
think that he was disloyal. I think that he was 100% American um and one he wasn't disloyal in that respect. Although some of the people that he picked to work on the atomic bomb were disloyal, and they were talking to the Soviets, and they did pass secrets to them. So that's not a myth. But
Right.
during the night, but let's get back to his
Okay.
scientific work,
All right.
and his
So
as a professor.
during this time, back to science and all
Yeah,
that. He
in
it, Go ahead.
I
Yeah.
was going to say quantum electrodynamics. He studied the interactions between electrons and photons using quantum theory. So that idea that when an electron accelerates, it exchanges a photon, that kind of physics. He explored something called vacuum polarization, and that led to some later groundwork for other corrections to the QED, quantum electrodynamic theory. Then also in about 1932, there was antimatter was discovered, and so he did some work with positrons, which were discovered, which is an antimatter electron,
Hmm.
and studied the behavior of the positron in electromagnetic fields. I mean, it's kind of wild, it's like you got these bubble chambers, and so a particle will decay inside of it, and then if it's an electron, it'll spiral in one direction, and they had another thing that would spiral around in another, and then decay. So the positron doesn't live very long. So, but it goes in the opposite direction. So it's like if you try to like forget everything about what you know about physics, and you go back in time and you think about, wow, this is wild. It's like it's an electron, okay, but it's got a positive charge, but it's exactly the same mass, and so anyway. So
His papers are still around, right? You can still find them and try to read it.
yeah, you can read his papers. Yeah, and
Okay.
actually in the textbooks, that Born Oppenheimer calculation is in the chapter in the textbook.
Yeah, yeah, of
So
course.
so he also contributed cosmic ray physics. They researched high energy particles entering the Earth's atmosphere, and so he was one of the people who proposed that the cosmic rays, these are particles that are coming from outside the Earth's atmosphere and impinging on it, and they would follow the magnetic field lines. Actually, they would spiral around the magnetic field lines, and so he proposed correctly that most of those were protons.
Hmm.
And that it contributed to something like what they call a particle shower in the atmosphere. So those occur. It's a high energy cosmic ray from outer space, and usually what it'll do is like it'll strike an atom high in the atmosphere, and then produces new particles. Some of these particles are other protons or neutrons, photons,
Hmm.
and they travel downward, and they collide with the atmosphere and produce
Cosmic ray
cascades.
showers. Okay.
Yeah.
So do you like? Can you actually see them? Like,
Well, the aurora is one of those is one manifestation of
things?
that. But what we see at the surface are things like muons and other kinds of
Right.
subatomic particles that
This is not what you would see by your eyes, but it could be
no
simulated. Yeah.
no
One one. What is this? What is T? Something. Electron
no
volt, proton hitting. Okay. Wow.
probably kinetic
So
energy.
yeah. So he came up with like this the initial theory to describe this, I suppose. Well, he was one of the ones.
That's
Yeah.
right.
Yeah.
So he contributed in nuclear physics, which is a related field. He studied nuclear forces, neutron-proton interactions, which
That would make sense.
right, which we
Right.
talked about. he clarified some of the processes in nuclear reactions and in fission.
So,
Long about this time, fission was discovered in Germany.
yeah, was he already working on anything nuclear physics when he was asked to direct the Manhattan Project? Or I guess
Well, the reason. Well, we'll get into the reason he was picked.
Okay.
And it had to do with the eclectic field that he had worked in. This wide variety, interdisciplinary physics, his ability to work with many different people, probably his knowledge and intimate knowledge of the people in Europe, and his ability to try to gather people together. So he also, as we mentioned about black holes and neutron stars, he was involved in calculating the maximum mass of neutron stars. That was one thing that people were talking about. So when a star collapses, that it goes to a point where we have just all of the neutrons. The electrons kind of get pushed into the proton, and they neutralize and become a neutron. And so everything. So that is kind of like a state of matter that exists in highly very stars. That was work he did with a guy named Volkov in 1939.
Coleman, Oppenheimer, Volkov limit. Well, that's a mouthful.
And then we already talked about the gravitational collapse.
Upper bound to the mass of cold, non-rotating neutron stars, analogous to the Chandrasekhar limit for white dwarf stars.
That's right.
Stars more massive than the TOV limit collapse into a black hole. Wow. Mm-hmm. So this places the limit approximately 0.7 solar masses.
So I think this broad theoretical range, working across multiple physics fields, quantum mechanics, statistical physics, nuclear theory, astrophysics.
It sounds like he's touched literally every part of physics.
That's my point. Okay, he was seen as one of the few American theorists that really matched the European physicist breadth and depth, right? So he was very influential, teaching, published fewer papers than his peers, but producing a lot of pioneering work. He was well known as inspiring, but also a demanding teacher. He mentored students who became, as we mentioned, he had a lot of students who became famous in their own right, and really established, at Caltech and UC Berkeley. He established the theoretical physics community in California. So in the early 40s, things were getting tense in Europe. They started looking at uranium fission. So he was influential, or he went to conferences. I don't know that he was writing any papers exactly, but he was having discussions and teaching and discussing fission, the fact that uranium will decay and then produce neutrons, and the whole idea of a chain reaction. And so there actually ended up being an atomic bomb theory group at Berkeley that they weren't. I don't think they were doing any experimental work, but they were doing the theoretical work on the atomic bomb at Berkeley. And in the meantime, so leading up to the Manhattan Project was the atomic bomb development project that was conducted by the United States during World War II. About the time of Britain was already at war with Germany, and so things were really heating up. A lot of this impetus to produce an atomic bomb came from British work, and then Pearl Harbor came along, and then Pearl Harbor, that was the entry of the U.S. into the war effort.
So by this point, America hasn't quite entered the war yet.
Well, by the end of 1941, they had.
Yeah.
But what I was going to mention was this thing called the British Maud Report. Maud, M-A-U-D, in all caps. And it's like, so this was a report as a secret assessment by British physicists, concluding that an atomic bomb was not only possible, but probably really quite likely could be built in just a few years. So a lot of people don't know this, that a lot of the impulse to develop the atomic bomb came from British science. And so, and then actually, the MAUD report, the name MAUD, it looks like an acronym, MAUD, and a lot of people think it is.
But you're saying it's not?
It's not. No, it has to do with an intercepted memo that involved Niels Bohr.
Manhattan Project.
Yeah.
It's actually, yeah, sorry, go ahead.
I said it's mistaken for an acronym, but it arose from some kind of telegram that Niels Bohr received or sent to his colleagues in Britain, and he referred to Maud Ray Kent, who was like his housekeeper.
Here, that was the first page.
And so I think the idea is it was presumed that had been intercepted by the Germans.
Yeah.
And so the way the telegram reads, it's like it's like some kind of code word for Maud Ray or Mother of Ray, and possibly hinting at radiation. In reality, it was just the English maid or governess that worked for the Niels Bohr family in Copenhagen. And so there was no secret meaning at all. So, but the British kept the name Maud Committee for the group studying the atomic bomb feasibility.
That's so funny. Not until after the war was Maud Ray Kent identified as a former governess of Niels Bohr's children.
And I want to say that is so British. You know, that kind of thing is almost like
Oh my gosh.
if you remember when we talked about radar, the name for the radar system was called Chain Home, right? And it's like Chain Home. What? Okay, so anyway, so this was part of that. But getting back to the report.
The MAUD report's really important in that it laid out how it basically encouraged America to develop a uranium program.
It promoted, prompted, or they were prompted by the early research into nuclear fission that was published really by the Germans. So people were terrified that the Germans were going to pick up on this. Okay, so the report estimated the amount of uranium-235 needed for a bomb. It outlined possible methods for isotope separation, meaning, as you know, maybe you don't. Uranium-235 makes up about 0.7% of uranium, and it's of the uranium metal. So we have something called uranium-235, and that refers to the mass of the isotope. So most uranium is uranium-238. Right, and so there's a tiny fraction, about 0.7% of natural uranium is this fissile form that
uranium
can be used to build a bomb. And so the idea is this MAUD report was really pivotal or seminal, we should say, in finding that this was really the effort was really decisive and practical. And they were really earlier than the American studies, which had been sort of cautious about that feasibility. But the MAUD report was shared with American scientists in late 1941, and it shocked the United States into action, convinced leaders. The Secretary of State of the U.S., I think it was Vannevar Bush, who was the father and grandfather of President Vannevar Bush, and also President Roosevelt, that building a bomb was not just theoretical, but a near-term possibility.
Right.
So the administration already kind of knew about the atomic bomb, about the possibility of building an atomic bomb, and they were getting very interested in it at that point. Then Pearl Harbor, which was in December of 41, increased the urgency. And then it turns out that Oppenheimer's theoretical leadership was very pivotal pivotal in that. So that brings us to the formation of the Manhattan Project in 1942. Some of the there was a general named Leslie Groves, um, and Groves was I think he went to the military academy, so he didn't have a he didn't he I I think that the military academy in those days did not have separate majors, different things, orders of areas of study. But he would have been like probably a mechanical engineer, and he later took some classes at MIT and so forth. So Leslie Groves, um, became acquainted or knew about Oppenheimer and the breadth and his ability to organize and lead things. And so even though Oppenheimer had some skeletons in his closet, the political concerns were overridden by the fact that he was very, very suitable for that. So Oppenheimer was selected by Groves to come and work on the project, and so they both of them started recruiting scientists, and I think they were having a discussion about, well, where are we going to place the laboratory? So they had laboratories all over the country, including in Oak Ridge, Tennessee, Hanford, Washington. There must have been some other place, but then Los Alamos, and of course, Oppenheimer was all familiar with that area. So as I mentioned earlier, in the early 20s.
I guess so Oppenheimer was the one who suggested Los Alamos?
I
Or New Mexico?
think he probably suggested it because
Yeah.
of remote location.
And he's been there and he liked the landscape.
He had been there, and so it was something of a coincidence, but probably not. Probably they could have located it somewhere.
There was at the time there wasn't a national lab there, right? Like
no. They built
it from this. They built that for the program.
They had infinite amount of funds, for developing this thing. Roosevelt was on board. He approved full-scale bomb effort after Pearl Harbor. They maintained extreme secrecy, a lot of the things. So the thing about Groves, Leslie Groves, who was the general, he was like part of the Army Corps of Engineers. And the Army Corps of Engineers, they do civilian work, like they build, dig canals and build levees and things like that. But they're also the people who build like a civil engineering kind of thing. And Groves, it's really a federal agency within the U.S. Army that still exists and is responsible for those kinds of things. So, but actually, the history of the Army Corps of Engineers, it goes all the way back to 1802, and so they have more than just this is an aside a little bit because I thought it was interesting. They have a role, and actually I also always kind of wondered about it because we always hear about the Army Corps of Engineers talking about civilian projects or civilian, and so they do have a mission to support national defense and also public engineering projects. So Leslie Groves, he oversaw a lot of. He was, I don't know if he was head of it, but he was important to the Army Corps of Engineers, and they developed the Pentagon building was built, and the Pentagon building was built. I'm not sure, but I think within a few months, like less than a year, to build the. From the time they started digging to the time they finished it, they built the Pentagon building, during World War II. And I want to say it was something like 7 months, or it was less than a year, I'm pretty sure. But so he had a lot of experience with secret sites and building facilities for, and they selected Oak Ridge, Hanford, and Los Alamos. And so the Army Corps of Engineers provided all the logistical expertise, the construction resources, and the ability to maintain the kind of secrecy that was required. So, so like I said, Los Alamos was chosen as the site.
So yeah, Los Alamos was chosen. He corralled a bunch of physicists together,
Right.
and
So
then they all
I
got going.
yeah, isolation and security. There were also actually there was some kind of ranch school, Los Alamos Ranch School, which had a facility. It had some dormitories, buildings, roads, and everything. So there was stuff that could be adapted, existing infrastructure that could be adapted quickly.
Mhm.
And so and then Oppenheimer's personal ties, with the land. So
So how deep do you want to go into the Manhattan Project?
well, I'm. What do you mean? How deep? We're gonna.
All right. So
This is
no, go on.
so. Oppenheimer was appointed as the scientific director of the Manhattan Project, and they began development of the atomic bomb. So, it was designated as Project Y, letter Y, and that was the code name for the top secret laboratory at Los Alamos. Okay, the whole Manhattan Project encompassed 3 different centers across the United States, but Los Alamos was designated as Project Y. So the whole so Project Y, which was Los Alamos, was the central lab tasked with designing and building the atomic bomb itself. And so Robert Oppenheimer, he led the development. So the whole job that they were undertaking was to calculate the critical mass that they needed, developing bomb designs. Okay, and there was 2 different kinds. They had this idea for a gun design, which is like they would have a subcritical mass of material on one end, and then another subcritical mass, and they would be brought together by basically shooting it down the barrel of a gun toward the other side. And then the other one was an implosion device, and that's actually it's figured prominently in the movie. You can see it where they have all of these explosive devices that would bring subcritical pieces of mass of fissile material all together into a like a sphere. And they conducted experiments, and they needed people who knew about explosives, nuclear physics, material science, assembling and testing. So anyway, assembly and testing of the bomb culminated in July of 1945. Actually, July 16th, and the 80th anniversary will be in 9 days, because today is July 7th, if I'm reading that right.
Today is July 7th.
Yeah, so it's 80 years ago, and Oppenheimer was the scientific director, and he coordinated all the scientific work. And General Groves was his boss and managed the military oversight and security. And like I said, the important things that they were trying to work on were those critical mass calculations and implosion design for the plutonium bomb. Was so they actually had to develop like high-speed diagnostics, like photographic means of measuring things that are that occur over a very short period of time. Oppenheimer recruited scientists, like a lot of people that are known, that are pretty famous, like Hans Bethe, Edward Teller, who was still alive and kicking, at the time when I was still in I think he was still alive when I was in graduate school. Enrico Fermi and Richard Feynman, okay, one of our favorite people.
Yep. We have mentioned a few of these.
So a lot of them were gathered together. Feynman was at Princeton at the time, and Feynman had a lot of unique things to say about traveling to Los Alamos. So they had a lot of the modern methods to secure secret information was kind of developed at this time. You would go into, like, there would be compartmentalization, which I'm kind of familiar with, where you would work on a particular area, and you wouldn't even know exactly how it would fit with other parts of the project. and they were also, all the people who worked on it were under surveillance and censorship, which Richard Feynman also talked about. Two designs for this thing. There was a little, and one of them was called Little Boy. That was the uranium gun type bomb. So that, remember, I described a gun where you'd have two subcritical masses. That's what they used the uranium for, or they developed for the uranium. And I don't know what it is that made them design one or the other. I think they wanted two designs. And then plutonium was the implosion bomb. So one of the interesting things about this science, or this engineering, is uranium needs to be separated. Uranium-235 needs to be separated from natural uranium, and that's done with various means like centrifuges or thermal diffusion and electromagnetic separation, so that you would use, because you can't do any chemistry. The chemistry of uranium-235 and of uranium-238 are exactly identical. Plutonium, on the other hand, can be created in a nuclear reactor using natural uranium. So a lot of people don't know this. Like you can build a nuclear reactor, like a reactor for breeding plutonium, because one of the things that happens is that usually what happens is the neutrons that come from the natural decay of the uranium-235 in natural uranium are going so fast that they don't react with the other uranium nearby in the matrix, and they just escape. But it was discovered at that time that if you could moderate the neutrons, in other words, certain kinds of substances could be used to slow down the neutrons long enough for it to react with the uranium-238, and then it would transmute. 238 would transmute into plutonium-239, and then you can separate the plutonium through chemistry. Let me do that. Let me explain that again, because it's kind of important for people to know this, even for today. Okay, a nuclear reactor can be adapted to breed plutonium. Plutonium is a fissile material that can be used in an atomic bomb, right? And so what needs to happen is that you need a nuclear reactor that has using natural uranium, and you concentrate it enough so that you have to insert within the matrix of the uranium some material that will slow the neutrons down. And the American side discovered that graphite could be used for that purpose, and they built a reactor. Leonard and the guys in Chicago. They built a nuclear reactor that could breed plutonium, and they relocated that effort up in Hanford, Washington. So that's where the plutonium was being developed. Other methods were being used to separate uranium-235 from natural uranium. So then if you listen to me carefully and you understood what I was saying, it might cause you to ask the question, well, if you can harvest plutonium from a nuclear reactor, why in the contemporary world we have this concern about uranium-235 being separated by using centrifuges by other countries and concentrating uranium-235? Why are they doing that? Why don't they just build a reactor to breed plutonium? And I'll pause.
What's the answer for that?
Well, the answer is not completely satisfying. They certainly could do that. Okay. Now the thing about it is that such a reactor needs to be pretty big. It's something that can't be hidden very easily. It requires a lot of support and that sort of thing. So it requires a lot of sophisticated engineering. And it turns out that the technology for separating uranium-235 from natural uranium, just extracting it, can be distributed over large areas. So in the contemporary in the concerning the issues that we've been dealing with lately, that that I'm thinking, the people 10,000 years from now really aren't going to care about this. But in the current epoch, we have this concern about a certain country developing an atomic bomb by separating uranium. And the reason they selected that is because they can have these centrifuges and they can distribute them over. It's scalable. You can do it over a large area. You don't need this central breeder reactor. I guess it's called a breeder reactor. But in fact, in the 40s, the Americans developed a plutonium implosion bomb that used used plutonium that was harvested from a nuclear reactor. So the first bomb that was at the Trinity site in New Mexico was a plutonium implosion device. Little Boy was the first atomic bomb that was dropped on Hiroshima.
Mm-hmm.
And then a few days later, another device that used plutonium was exploded.
These were all developed at the Los Alamos?
At Los Alamos, at Oak Ridge, Tennessee, and at Hanford, Washington. Hanford, Washington was more like an industrial plutonium production area. Oak Ridge was where they did the uranium. I think there was a lot of overlap between them. So that's what happened. So on July 16th, the bomb was ready. And the first atomic explosion in human history occurred at a place called Alamogordo, New Mexico. It yielded about 20 kilotons of the equivalent of 20,000 tons of TNT, and the whole group witnessed it. Oppenheimer later said that he was a well-read person, and perhaps he had some spiritual thoughts or something like that. He was interested in Hindu theology, and so he said that, and this is kind of famous. He said that what went through his mind. Some people say that he recited this poem from the spiritual text of the Hindu religion, but he did not. He said it went through his mind, and it's interesting that it's known. He said that now I become death, destroyer of worlds, and that's part of a I guess a liturgy between it's a discussion between two characters in the scriptures. One of them was named Arjuna, and actually I'm a little hesitant because we have people that know much more about this, like maybe people who are Hindu or know about this. So if I'm butchering this, put your comments in there and accept my apology for not explaining this correctly. But there's one character called Arjuna who was a warrior. It's like a prince. And he's reticent. He doesn't want to really fight in a civil war with his own relatives and teachers. And then Krishna is his charioteer, who's an incarnation of like the big god Vishnu. And so Arjuna is, are you ready for this? He's tormented by moral doubts about the fighting, and Krishna counsels him on his duty. Okay, so the reason Oppenheimer, and I don't know, people don't talk about this. The reason Oppenheimer was talking about this was that he felt like he was in the role of Arjuna, a soldier who had his duty to create this weapon, right? But he was also having moral doubts about the impact of what they had done. So I thought that was an interesting. I mean, that's kind of my own analysis of that. I didn't really read that anywhere, but that's what I think that he was thinking about. I haven't found anyone to say yes or no. I think that Oppenheimer was was channeling Arjuna and also Krishna, those two characters. Not that he was God or anything. It's just that he was channeling the moral dichotomy or moral struggle, and that's why he was saying how I become death, the destroyer of worlds. So, because the character Arjuna was tormented by moral doubts about fighting, and certainly Oppenheimer was like that. And yet he had the duty to do this thing. So I thought that's my own thesis. Probably it's not original, but I haven't seen it anywhere.
That book is original.
So I don't know, but they produced 2 usable bomb designs, and the atomic bombs were dropped on Hiroshima and Nagasaki. And Oppenheimer became afterwards. He became increasingly troubled by the implications of what he had done. And I've heard or I've read that other physicists who were working on the bomb kind of had this same effect, like when they were driving along the highway, and they would see a truck stop, or you would see a hotel or something like that. You're thinking, my God, everything's already been destroyed. They had this idea that everyone's already dead in some respect, because they didn't think that you could keep this thing under control. So, anyway, the really early worries were about Germany, right? So that the discovery of nuclear fission in Germany raised the fears that the Nazis would have an atomic bomb, and this is backing up a little bit. Edward Einstein, Szilard. So Szilard, they had a letter, which I think we've mentioned in previous episodes.
We definitely have.
Warned the Germans, warned Roosevelt about the potential for a German bomb. And in that letter, Szilard thought that the letter was really written by Szilard, but Einstein signed it. They thought that the bomb could be put into a ship or something and snuck into a port, right, and then destroy the entire city. So, but it turned out that the Germans were working on a uranium program, and they started in 1939, and it was Werner Heisenberg and Otto Hahn. Otto Hahn is the guy that discovered the nuclear fission, and so Heisenberg was sort of a chief figure in the bomb effort, and the Americans were, thought it was highly, they were very much afraid of that, where that would go. So in 1941, Heisenberg and Bohr met in Copenhagen, and then the Maud report came out. So now here's the thing. Here's where I'm building up to. After the war, because I think we know the history. Just a sec.
Are you back?
So yes, I'm back. Review. So Heisenberg and some of the other scientists were captured, and they were taken to Britain, and in a place called Farm Hall is where they were maintained. And so this is in 1945, right? And around July is when the Trinity test was undertaken. They still didn't know about it, but by August, the atomic bombs on Japan had become public knowledge, and they listened to the German scientists that they still had captive in England, and it showed that what these transcripts. In other words, they had microphones all over the place where they were keeping the German scientists, including Heisenberg. That they were very far behind, and so when the Germans learned about it, they had no idea. I mean, okay, let me say, they presented Heisenberg and the others with this fact that the Americans had an atomic bomb, and they were absolutely stunned. They had no idea the Allies were so far along. They, the Germans never built a working reactor, let alone a bomb, and it proved that Germany was nowhere close to developing a nuclear weapon during the war. So their program was small, fragmented, underfunded compared to the Manhattan Project. So Heisenberg was really confused. He misunderstood the bomb's physics, and after Hiroshima, he tried to calculate the bomb's critical in mass, but got it wrong by orders of magnitude. He thought that there was a couple of orders of magnitude more material needed than was actually used. So he didn't grasp. So Heisenberg was very far behind. They were also trying to remember I said about having a reactor where you use graphite to slow down the neutrons.
Yeah.
Well, heavy water can be used for the same purpose, and the Germans were working on a heavy water design for a reactor, and they didn't, like I said, they didn't get very far. There was a not a commando raid, but a special air raid on a plant in Norway that the Germans occupied, which is famous, and they blew up all of the heavy water that had been built. They had hydroelectric hydroelectric plants that were used to separate deuterium from natural water to develop the heavy water. There's also some thoughts about, more the way talking about the moral conflict that Oppenheimer had. That didn't seem to affect Germans at all. I like to think that Heisenberg was holding back. I kind of want to believe that, but there wasn't really any evidence that was the case. So
You're saying Heisenberg didn't really feel very bad about developing a bomb?
Well, some of the scientists had some relief that Hitler didn't get the weapon first, but I think probably they didn't get far enough along, and that to start having those kinds of
ideas, internal guilt or questions,
right?
Whatnot, yeah.
So the reason that kind of relates to Oppenheimer is Oppenheimer later started having very serious conflicts, in his own problem and his own person, his own moral sense, right? It also shows that the Germans didn't penetrate the secrecy of the atomic bomb effort that the Americans were undertaking. Neither did the Japanese. The Japanese also didn't know anything about it. And the Japanese thought that there was something going on at Los Alamos, but they thought it was like a conventional explosives.
Right. They didn't think at all that it could be something like an atomic bomb. Yeah.
So that means that there was no leakage of information to the Axis, to the bad guys in World War II. However, when the atomic bomb was revealed to Truman, because Roosevelt was dead at that time, they had a meeting. The Allies, including Churchill, Truman, and Stalin, had a meeting at a place called Potsdam, and Truman mentioned this new weapon, but the Russians already knew about it, and that's because the scientists that they had hired at Los Alamos were leaking information to the Soviets. So Stalin didn't really have any surprise about it. I think he said something like, "Yeah, go ahead and drop it." It's like he thought he acted like, "Oh yeah, it's just another bomb." Right. So there were Soviet spies that had infiltrated the Manhattan Project, and
Hmm.
that is kind of a failure that of um, of uh, of
Hmm.
Oppenheimer and General Rose. So they passed some critical design details to the USR, and it greatly accelerated the Soviet bomb timeline. So their project really was started in the summer of 1945 under a group of scientists, um, prominent scientists. And the first atomic test by the Soviets was in 1949. So they had a rapid development also. One of the things is that the Soviets were also very much aware of the delivery systems that the U.S. has in the form of the B-29. So they were very interested in overcoming that. So really, that whole thing, that whole event in August 29, 1949,
Hmm.
the Soviets exploded an atomic bomb
Hmm.
that
What,
sparked the Cold War nuclear arms race.
what was Oppenheimer doing at this time after the
Well,
Manhattan Project?
that's a good question. That leads me into his views on control of the bomb. So in late 45, after Hiroshima and Nagasaki, um, the bomb really did end the war quickly, and we could talk about that another time, perhaps. But
Hmm.
um, the Oppenheimer, and of course, most Oppenheimer realized that the bomb would transform geopolitics and also the moral dimension. And of course, he quoted that thing from the Hindu scriptures.
Yep.
I'm become death, the destroyer of worlds. I remember when I was in grade school, they showed us film of Oppenheimer. Uh, I think it was from a 1965 TV show where he was interviewed, and
Hmm.
he mentioned this in the show. So, um, but what he wanted was in the year after, or the couple years after World War II, before the Russians had exposed the fact that they had a nuclear weapon as well. He wanted international control. He was very deeply worried about a nuclear arms race. He advocated international scientific cooperation, placing nuclear technology under international controls. And in that time, there was something called the Acheson-Lilienthal Report
Hmm.
that proposed an international atomic energy or atomic development authority that would provide like they would provide they would prevent like secret development somehow and also proliferation. And then that led to something else called the Baruch Plan. So uh, I was just getting a text. I had to.
All good.
You know how that is. And the Baruch Plan was a U.S. proposal on the Acheson-Lilienthal ideas, offering atomic knowledge sharing under strict inspections. And this was all Oppenheimer's doing. He was trying to support this thing. And of course, in the movie
Mhm.
Oppenheimer, which I don't know if we've ever mentioned it,
I
Oppenheimer
mentioned
is
the movie in the beginning, but we didn't really talk
yeah,
about it.
Oppenheimer is seen meeting with Truman, and it's an awkward scene. It's not really well done, in my opinion. Um, but that's just the artistic impression of that. But that meeting actually did happen, and apparently it is true that Oppenheimer was uh, trying to tell Truman that Oppenheimer, I'm responsible for this, and I'm the one who did all of these things. And Truman got angry at him and said, "Look, you didn't." It's apparently true. He said, "You didn't. You didn't kill all those people." He said, "I did. Okay, I did the
Mm.
order. You were just the instrument for creating the bomb." And I think Truman was right about that. Okay, so but at any rate, all of these international proposals for that's my opinion. I think Truman was right. Okay, Oppenheimer had an entirely naive idea about how this technology could be constrained. Um, and this and at any rate, the Soviets rejected the proposals for sharing of the of the inspections course. That's because they were hot on the research development of their own atomic bomb. And so anyway, by 1949, the atomic test ended the U.S. monopoly, and
Hmm.
Oppenheimer realized that mutual suspicion would block international control. So now, what's coming on after that was Edward Teller. Okay, Edward Teller was one of the prominent physicists of the Manhattan Project, who, as I say, seemed to have lived forever. I think he was still around when I was in graduate school. So they were talking about what's called the hydrogen bomb. So the hydrogen bomb is exploits an atomic bomb, using uranium or plutonium to create a high temperature environment, and which would then lead to fusion
Hmm.
of hydrogen isotopes, tritium or deuterium, or protons, into like an auxiliary explosive, a nuclear explosive that you could use that would be triggered by the atomic bomb. Hydrogen bomb is virtually unrestrained, unconstrained. There's only so much yield you can get from an atomic bomb, but the hydrogen bomb, the fusion device, can be built almost arbitrarily large, right? And so Oppenheimer, once again, his moral sense kind of kicked
Yeah,
in,
of course.
and he opposed the rapid development, and he's quoted as saying it was a weapon of genocide. This is the hydrogen bomb, and this
Right,
was
right.
all during the period just before 1950, where there was debate over the H-bomb development. So, but he thought that there would be he thought that the world was coming to an end, right? And so opposition became central and here we come to the security hearings of 1954.
Hmm.
So a lot of people thought that because of his opposition to developing the hydrogen bomb, that he was disloyal, certainly naive, in my opinion. Even though I'm kind of a pacifist myself, but
Right. I mean, you're wearing a
uh,
little peace symbol around your neck right there.
thank you for noticing. So, so in the security hearings, which are also depicted in the movie, and this was in December of 1953, Oppenheimer's security clearance was just suspended by
Mm.
the Atomic Energy
Because
Commission.
he did not want the development of a hydrogen
Well,
bomb.
he didn't want the high development of the hydrogen bomb, but it was based on allegations of past communist associations.
Oh, because what he did in
Okay.
the 30s. Yeah.
There were some inconsistent statements to security officials and concerns about opposition to building the hydrogen bomb. Um, and so in the movie, this is like a central theme of the whole movie.
Hmm.
And I don't know. I what was the purpose of him having a security clearance? Okay, the Atomic Energy Commission at those times, it's the Atomic Energy Agency these days, but they were developing the hydrogen bomb. They needed people with security clearances to build the hydrogen bomb. Okay, Oppenheimer didn't want to build the hydrogen bomb, therefore you're not entitled to a security clearance. We don't need you to do this. Oppenheimer wanted to stay in the program to fight against it, right? So it's like, I don't know exactly what to say about that, except that they suspended his security clearance, and then then he fought that he wanted to fight that, and they convened what's called a personal security board to hold hearings, decide whether Oppenheimer should retain the security clearance. And the hearing panel was led by important people in the agency, which it doesn't really matter who they are. But the hearings were held in Washington D.C. between April and May of 1954, and they were administrative proceedings. Some people think that it was some kind of trial. Okay, he wasn't criminally charged with anything. Okay, but they were kind of conducted like a legal investigation, and so they did a real probe a real download of his background. And so and actually they were secret, and eventually
Hmm.
they were made public through transcripts. I don't even exactly know how they were made public, but so the government case was presented by lawyers, and they questioned Oppenheimer and portrayed him as unreliable and a security risk. The hearings focused on issues. The main issues were political associations during the 1930s, including friendships and donations connected to communist organizations. There was something called the Chevalier incident. Um, Oppenheimer had a friend named Hakon Chevalier who approached him indirectly, and I think this is depicted in the film also, and indirectly in 1943, about passing information to the Soviet Union. Oppenheimer initially minimized the event, and then his story changed. So he it's almost like he tried to hide it, okay? Like he didn't want people to know about it, and then he said, "Oh yeah, well, yeah, I met with him," and it honestly, honestly, it's suspicious. I mean, I I I don't think that Oppenheimer was passing stuff to the Soviets, but he was he was contacted by a communist friend while they were working on the Manhattan Project. So it does raise some doubts about his credibility. Oppenheimer's opposition to rapid development of the hydrogen bomb. Some officials saw that as a sign of disloyalty, or at least poor judgment during the Cold War. And these are concerns over whether Oppenheimer had been candid about the security with security officials in the early investigations. And so that's kind of the true story, I think. Several prominent scientists testified during the hearings, including his boss Leslie Groves. They spoke favorably of him. They said he was loyal, made many contributions. Edward Teller was not so sanguine about him, and wondered about his suitability for continued access to classified information. And so, ultimately, the hearing board concluded that Oppenheimer was loyal to the United States, but that he had some character flaws, including things like wanting to try to make this communist Soviet agent who had come to him. I can't imagine being approached by a Soviet agent, right? And then not turning him in, or which is how I read it, right? Or not immediately going to the security people to tell them, look what happened here. So the meeting was convened, and they voted 4-1 to revoke his security clearance, and the decision effectively ended his role as a government advisor on nuclear policy and damaged his public reputation. Now, before all of this happened, Albert Einstein had talked to Oppenheimer. I don't know if he visited, or whether maybe he visited him, or they got together, or maybe it was just on the phone. I don't know. But Albert Einstein advised Oppenheimer to walk away from the process, telling him he should stop worrying about what Washington thought and return to his scientific work, which is what I think he should have done. Okay. Oppenheimer, however, felt compelled to defend himself. And after the hearings, Oppenheimer withdrew from government service, focused on his academic work, public lectures, and over time, some sympathy started to grow for him. And in 1963, well, it couldn't have been in 63 or 64, the president awarded him the Enrico Fermi Award, which was a prestigious award signaling partial rehabilitation of his reputation. So anyway, that's kind of the end of the story. His security hearing was pivotal. He continued to lecture and talk about these things, and he retreated from political influence, focused on teaching, writing, and of course his philosophical reflection. But he never really did any kind of any kind of serious science after that, which is a little bit surprising. Um, so he often his philosophical reflections often express profound doubts about humanity's ability to control nuclear power. He expressed concerns about secrecy, militarization, and his moral responsibility. He used to cry a lot. I mean, in that 1965 television show, he's like very morose and weeping, that kind of
Hmm.
thing. So, and you remember he tried to poison his professor. Okay, so and that never came up in that never came up in his security clearance. I don't think so. It's a little so, but anyway, it's kind of a sad ending to the story. I think that he did remain director of the Institute for Advanced Studies, so he moved over to Princeton, and he did mentor young scientists, but he was no longer consulted on U.S. nuclear policy, and that created a lot of professional isolation. But sort of in my sense, self-imposed. So in the end, sometime in the late '60s, he was diagnosed with throat cancer. I guess I never mentioned that he was a chain smoker, as was everyone else.
Well, I mean, yeah, I assume everybody did that back then.
So, well, I mean, um, that was the anti-anxiety medicine. Like today we, like we scream at the sky, and we,
Oh my gosh.
we, you do all kinds of ridiculous and futile things when you're faced with existential dread. But in those days, you just smoked a pack of cigarettes.
And that tends to shorten your lifespan, though. No, yeah. So,
Right. So he died he retired from the Institute for Advanced Study in 1966, and he passed away quietly in February of 1967. So his legacy, he can be remembered, and I think he was just 62. So when I was his age, I had been dead for 5 years. When I was
wait.
Oppenheimer's age when he died, I would have already been dead. No, he was okay. So he died in 1967 at age 62. Okay, which is kind of premature, yes.
Right.
So he's remembered as a brilliant physicist, which I think is true, and a key figure in the Manhattan Project. He made significant contributions to quantum mechanics, astrophysics, and theoretical physics. He's become an enduring symbol of the moral burden of scientific discovery. He sparked debates about scientists' responsibility for how their work is used. He's seen as a tragic, complex figure whose genius helped win a war, but who carried the weight of nuclear weapons consequences. So, the end. That's kind of all I wanted to say. That's quite a lot.
That's absolutely quite a lot. I think this is our longest episode yet, running almost 2 hours long. So,
I told you I thought it was going to be a long one. Yeah.
All right. For anybody still paying attention here, I'm glad you were able to keep your attention on the show for almost 2 hours long.
Yes.
So understandably, there was quite a lot to unpack there. Since this is what happens when you talk about a guy who's done so much. So
that's right. I didn't know any way other to do it unless we split it up into 2 episodes. We could have done that.
I don't know how that would have worked. Yeah.
Oh, we did that for.
We did that for Von Braun, I think.
Von Braun.
Yeah, we did. That is true.
So that's my story.
All right.
That's what I've learned about Oppenheimer. It's a little kind of more than I knew before, but
I would say it's quite a lot. So
he was, I remember, I don't know if because when he died in '67, I was 9. I don't know that I knew about him before he died. I don't think so.
You said you
No.
watched some 1965 TV show with
I
Oppenheimer.
remember the social studies class, probably
Hmm.
fifth grade. In fifth
So,
grade, and there was a pretty sure it was fifth grade, and they showed us it was not the broadcast TV show, but it was a TV show on probably CBS or something, where they interviewed him, and he didn't acquit himself. You know, he was very morose, and I just distinctly remember that. I'm sure you could find the TV show on YouTube. I mean,
yeah, for sure.
you can find everything else.
You can find anything else, including the real Oppenheimer, on YouTube. I'm sure. I'll
Yep.
find some links and I will put it on
So-
here. So, with all that said, thank you for your expose. For our audience here, if you have any remaining questions, of course, feel free to put them in the comments.
Like, subscribe.
And as always, thank you to our Patreon supporters, John Graves, Kyle Baker, also Joy Jackson, Geoffrey, and Barnes. Thank you to all our listeners and people who are subscribed as well on YouTube. As Leonard has kindly pointed out, like, subscribe, share, since we like doing that. Get the word out, so to speak. And if you have any suggestions, let us know. So we haven't yet decided on our next topic for the week, for next week. So we will inform you guys on the Patreon page when we decide that. So with all that said, I have nothing more to say, and
I don't have anything else to say.
that's it, I guess. All right.
So, all right. Well, namaste.
Namaste. Shalom. And all that.
Thanks for stopping by.
Thanks for stopping by. And to our viewers from 10,000 years in the future, you already know all this.
You already know.
But
Yeah.
I'm sure you still find it entertaining for people to talk about it.
We're an artifact to be studied.
Yes, or indeed. All right. Take care.
Good night.